Hello, my name is Zedekiah Narvasa. I will be the one presenting the data that will be used for the rest of this video. So before that, a little bit of background about the data we'll be using. The University of the Philippines is one of the country is the country's national university, and where a lot of students every year apply to try and get into their college program. At an average, around 100 students apply each year, and only around 10 to 15% of them pass every year. So the data set that we'll be using will be focused on this college test, the UP College Administration Test. Wait, let me switch. Okay, there. University UP College Admission Test. So we will be the, the timeline of this data will start from 2016 up to 2023. And here it will this will be in the rest of the video, but here's a list of all the sources that we had for the data that we'll be using. Now, here is the compilation of all the data that I have gathered after a few hours of research. As you can see, uh, firstly at 2016, there's only 10,000 applicants because of the new K-12 program. So that's why the number has been really small, with only like 1,500 passing. But ever since 2017, there's been at least 100,000 applicants per year. And some of these are estimates of of the people admitted and the number of applicants, so they're not fully accurate. But it is hard to find accurate measurements of the data. So after the compilation, I was able to solve for the mean, which is 10,581, standard deviation of 3,673, and an average passing rate of 12.3%. I'll leave it to my other group mates to explain their problems about to explain their problems and show their solutions.
Good day everyone, my name is Blaine Atil from 11th Dynasty. Now that the data has been given to us by Zedekiah Narvasa, we'll proceed to answering problems. The problem is, the administrator of UP College wants to know the mean number of college applicants who passed in the years 2016 to 2023. He computed a mean of 10,591 students with a standard deviation of 3,673 students. Construct a 95% confidence interval estimate for the mean number of applicants who pass. For this type of problem, we'll use the formula sample mean plus or minus z times standard deviation divided by the square root of sample size. These are the given values of the problem. Sample mean is 10,581 and our standard deviation is 3,673. Our sample size is 8, which is the number of years. And our z-score will be, what will be our z-score in this problem? Z-score is the value corresponding to the desired confidence level. So our z-score will be negative 1.960 and 1.96 since it corresponds to the 95% confidence level. Now that we have the given values in the formula for this problem, we can proceed with solving it. We'll first solve the lower limit. Substitute 10,591 minus 1.96 times 3,673 divided by the square root of 8 will be 8,045.74. Since this is a discrete variable, we will not round it off and our final answer will be an integer. So this will be 8,045. We'll do the same to the upper limit, but we will add the sample mean and the product of the z times standard deviation divided by the square root of sample size. 10,591 plus 2,545.26 will be 13,136.26. And our final answer as an integer will be 13,136. Therefore, the 95% confidence interval estimate for the mean number of applicants who passed in the years 2016 to 2023 is 8,045 to 13,136 students.
Hi, my name is Shawnette Montinola, and I'm here to solve a problem. So the problem is the administrator of an educational institution wants to know the mean number of UP college applicants who passed in the years 2016 to 2023. She computed a mean kay 10,591 with a standard deviation of 3,673. Assuming the number of applicants who passed is normally distributed, what is the probability that a randomly selected year will have an average greater than 10,000? So, since here we have the mean of 10,591 and a standard deviation of 3,673 and an x of 10,000. So what we'll do is x equals 10,000. Sorry for my handwriting. Minus 10,591 and divide 300. Ay, boy, divide 3,673. So here we divide. So the answer is negative 0.16. And here, we draw the kuan. Uy, sorry if it's ugly. Here. So it's gonna put negative 2, negative 1, and 0, and 1, 2, 3. So since it's kuan, it's the graph na ni, is the graph. So greater than man siya, so sa right siya is shade. So here, since it's 0.16 man, let's shade it na. Uy, ugly na eh. I'm sorry. Since it's 0.16 man. Since na, since it ko, since naigo man ang mean, so mao na, i-plus. So since naigo man siya ang mean sa pag-shade, so i-plus siya. So i-plus, so okay, let's go. 0.0636 plus 0.5 thousand. So plus 0.5636. So ang answer is 0.5636 or 56.36%. So that is the answer.
So the problem we have here is that the average college applicants who passed in the years 2016 to 2023 is 10,591, with a standard deviation of 3,667. Assume that the number of applicants who pass is normally distributed. What is the probability that a random selected year will have an average more than 9,260? So we have the given here. The raw score is 9,260. The mean is 10,591 and the standard deviation is 3,673. Next, we're gonna get the z-score from the raw score, which is we're gonna use the formula z-score equals raw score minus the mean over standard deviation. So we have 9,260 minus 10,591 divided by 3,673, resulting in negative 0.36. We have the z-score here. Using as area of the normal curve, we can see that the negative 0.36 is on the left side because it's negative. So we put a line there. Next is we're going to look for the area of the z-score using a z-table. 0.3 and 0.06 becomes 0.64058. Next is we're gonna have to subtract it from 0.5 thousand. We're gonna have that as we're gonna have a sum of 0.1406. Referring to the z-table, we find that the value of negative 0.36 is 0.1406. Next, we are gonna calculate the percentage. To determine the percentage of college applications who passed in the years 2016 and 2023, we subtract the z-table values, which is 0.1406 by 0.5 thousand, and multiply it by 100. We have 0.5 thousand minus 0.1915 equals 0.6406. Next, we're gonna multiply it by 100. So we have 64.06%. Therefore, the probability that a random selected year will have an average more than 9,260 is 64.06.
Hello guys, today we'll be solving a problem involving statistics. Here we have a problem of the administrator of an educational institution wants to know the mean number of UP college applicants who passed in the years 2016 to 2023. She computed a mean of 10,591 with a standard deviation of 3,673. Assuming the number of applicants who passed is normally distributed, what is the probability that a randomly selected year will have an average lower than 10,000? So first we have to take note of the given values. We have a mean of 10,591, a standard deviation of 3,673, and a raw score of 10,000. So using this formula, we will find the z-score of our problem. So first we have the raw score, which is 10,000. 10,000 minus the mean, which is 10,591, divided by the standard deviation, which is 3,673. So we'll have our calculator do that. So 10,000 minus 10,591 divided by 3,673, that would be negative 16, negative 0.16. So we have to find a negative 0.16 in our z-table. Negative 0.16 would be 0.4364. We have that here. Since it's negative, it is definitely on the left side of the graph, and we are supposed to find what is lower than 10,000, which is we'll have to find the lower one, and lower means we'll go left, so we'll stay 0.4364 as is. We won't add 5,000 or minus 5,000. So 4364 to a percentage would be 43.64%, and that is our answer.